Hey guys, this is question MM017 of the Sharpen Maths Methods Study Guide. This question is specifically talking about simultaneous linear equations. We've got a constant m within these equations and we need to find the value of m that produces infinitely many solutions between these two equations. What it means by solutions is points of intersection. There is a full explanation on how to do this in another video, or how to understand this rather, in another video, and also at the start of the study guide. So let's get into it. So first thing I like to do is rewrite my equations as 1 and 2. Now, in order to compare these, like I've mentioned in a previous video, we need to get it in the form y equals mx plus c. So let's start with the first equation. We've got 3x plus my equals 0, which equals my equals negative 3x, which means that y is equal to negative 3 on mx, with no c value, which is a lot easier than regular questions. Our second equation is m take 5 times x plus 2y equals 0, which means that 2y equals negative m take 5x, which means that y equals, and you sort of just expand this, 5 take m over 2x. So these are our two equations, and note that they both don't have any c values. So when this gradient equals the same, well, they actually do have a c value, it's 0. So these two both have a point of intersection at y equals 0. So when these gradients are the same, that means they have infinitely many solutions because they're actually the same graph. So what we want to do from here is equate those gradients. So we've got negative 3 on m equals 5 take m over 2. Now you just cross multiply across, so negative 3 times 2, which is negative 6, and then m times 5 take m, which is 5m take m squared. Now we want to get everything onto one side so that we can have a 0 on this side. I like to keep the m squared or a squared or whatever number or whatever letter you're using positive. So I'd bring this over this side, which gives us m squared take 5m take 6, and then this side will be equal to 0. So I've just kind of swapped it around to make it a bit easier to see. We then factorize this. So this then becomes m take 6 and m plus 1, because negative 6 times 1 is negative 6 and negative 6 plus 1 is negative 5. From here, we then know that m take 6 equals 0 and m plus 1 equals 0, according to our null factor law. If you're not familiar with that, go through your textbook and have a look at that, which gives us m equals 6 and m equals negative 1. Now, because there's no c values, we know that when m equals 6 and m equals negative 1, the c value is going to be the same anyway, which means that these two equations are going to be equal, which means that there's going to be infinitely many solutions for these two values. So when m equals negative 1 and 6, just be careful about which value you choose. These ones are negative 6 and 1, so we don't want to worry about any of these. B and D may confuse you a little bit if you're not too familiar with this, but essentially we've just figured out that if m equals negative 1 and m equals 6, then there's infinitely many solutions, so it's B. D is actually excluding those values, but we don't want to do that, so our answer is B.